Let's go ahead and do a complex familiar for a social networking problem. The diagram shows friend connections on Facebook. If there is no direct or one-step connection between two people, they don't communicate directly. Now what this means, if you just have a look with Craig, for instance, so Craig has got a direct one-step connection with Kate and Alicia. But if he wants to get a message to Jack, he's got to go through Alicia. Now the first part of this problem is A, show all direct one-step social links in a matrix A. So the first step is to lay out your matrix as shown. So each person gets a letter for their name, so K, F, M, J, A, C, and they're laid out as shown in the matrix, top to bottom and left to right in the same consecutive order. Okay, let's look at Kate first. So going to K. Now she can't communicate with herself. She's got a connection from Kate to Craig and from Kate to Felicity. So Kate has got 0 connections to herself. Now just a quick note there, if there was a loop like that around Kate, then yes, you would have to put a 1 in the KK position. Now going ahead to KF, so communication between Kate and Felicity, yes, there is communication, and there's a one-step direct arrow, so it's a 1. Now if you look at the K here, you've also got KF in this area, so you put a 1 in that column as well. Now looking at Kate and Mel, so Kate does not have a direct arrow connected to Mel, so 0. And again, we put 0 down here. Kate to Jack, that's another 0 because there is no direct line arrows running from Kate to Jack. Kate to Alicia, 0, 0. And finally Kate to Craig will be a 1. Now the reason that we're doing a 1 in 2 positions is because as you've noticed, there's an arrow on both ends of the connection. If Kate could only communicate with Craig in one direction and Craig couldn't communicate with Kate, then you would only have a 1 here and you'd have a 0 here. Moving on to Felicity. So we go to the second row. So Felicity can't communicate with herself. So that's a 0. Now, Felicity and Mel is a 1 because there's this direct communication here. Felicity to Jack is a 0 because remember we're talking about one-step direct communication here. Felicity to Alicia is a 1 because there's this connection here. And finally Felicity to Craig, no, there is no direct connection. She'd have to communicate through Kate or through Alicia. So 0. So just finishing filling this one in, Felicity, because remember there's two-way communications, so both sides will be the same. Now let's go ahead and look at Mel. So that's row 3 and column 3. Okay, so Mel has got a direct communication with Felicity. So we've got that already. Mel to Mel, she can't do that, so it's 0. Mel to Jack, yes, there is a direct communication here. So that is a 1 in that position and in that position. Mel to Alicia, yes, there is a connection here. So Mel to Alicia is 1. And finally Mel to Craig, No, that can't happen, so that's a 0. And let's just fill the rest of that column out because it's symmetrical, it's all the same because there's two-way communications. Alright, working with Jack, so row 4 and column 4, some of it's filled in already. Now Jack can't communicate with himself. And then Jack and Alicia, yes, there is one direct communication. So let's put a 1 there and a 1 there. Jack and Craig, there is 0 communication between Jack and Craig. 0 one-step communication. Alright, now moving on to row 5, Alicia and column 5. So Alicia, some of them are filled out already, so Alicia and Alicia, 0. And then the only one we need to fill out is Alicia and Craig. So there's a 1 there and a 1 there. And of course Craig to Craig is a 0. So in an exam they might ask, why is there a diagonal of zeros? And that, as we discussed before, was because they can't communicate with each other. Also, they may ask why it's symmetrical about that diagonal. For instance, 1 1 0 0 0 1 1 0. Well, that is because if you look at these arrows, there's two-way communication. Kate can communicate with Craig, Craig can communicate backwards to Kate. Otherwise, it wouldn't be symmetrical. Now let's move on to part B. Show the number of two-step ways these friends can communicate. Now two-step means, for instance, if Craig wanted to communicate with Felicity, he could go through Kate to get to Felicity. Or if he wanted to go through Alicia, he could also go through Alicia as a two-step to get to Felicity. Kate cannot communicate with Jack via two steps. She'd have to go through Felicity, then Mel, then Jack. So she doesn't count. Kate to Jack does not count as a two-step. Now, as far as matrices go, it's actually quite cool that if you square the matrix, you will be able to find all the two steps immediately without having to do anything else. So this is what we're going to be calculating. So we're going to go ahead and we're going to calculate row by row the matrix multiplication, and then as we go we'll enter each result into this matrix. So it's actually quite a long process when you're working with a 6 by 6 square matrix. So starting with Kate's row on the left and multiplying out by Kate's column, we'll have 0 times 0 plus 1 times 1 plus 0 times 0 plus 0 times 0 plus 0 times 0 plus 1 times 1. And that equals 2. So we go ahead and we put the value 2 in for A11. Now for the A12 position, we're still working with row 1, Kate, but now we're going to work with column 2, and that is Felicity. So A12 is equal to 0 times 1 plus 1 times 0 plus 0 times 1 plus 0 times 0 plus 0 times 1 plus 1 times 0. And that equals 0. So we go ahead and put a 0 in for A12. Now we go ahead and for position A13 we multiply row K by column M. So A13 is 0 by 0 plus 1 by 1 plus 0 times 0 plus 0 times 1 plus 0 times 1 plus 1 times 0, and that equals 1. So we go ahead and put a 1 in there. Now if you continue with the same method, only this time row K multiplies by column J, you'll end up with a position A14 equals 0. And then you do row K by column A, which will give you a 2 using the same method. And then lastly you would do row K by column C to give a value of 0 for 1 6 position. Once we've worked out the first row of the new matrix, we can go on to the second row. So now we're using the second row, which is Felicity, and we're going to multiply out by each one of these columns to get each of your positions in row 2 of your new matrices. Alright, so for A21, we've got this multiplication to do. So A21 is equal to 1 times 0 plus 0 times 1 plus 1 times 0 plus 0 times 0 plus 1 times 0 plus 0 times 1. So that equals 0. So we go ahead and we put that in position A21. So using the same method, we multiply position A22, we're going to multiply row F by column F. So we've got 1 times 1 plus 0 times 0 plus 1 times 1 plus 0 times 0 plus 1 times 1 plus 0 times 0 equals 3. So let's go ahead and put 3 into that position. Okay, for item 2-3, we're multiplying row F by column M, and same procedure as before, so we end up getting a 1. And we go ahead and write a 1 into this position. Now without showing you the further working, because it's all the same method, so this time we've got for A24, we're still using Felicity's row, and now she's multiplying by the 4th column, which is J, which is Jack. So that works out if you multiply it out to be 2. So put that in there. So again, using the same method, only this time it's row F times column A gives you a 1. And again, using the same method, still multiplying by row F, and row F is multiplying column C this time for the final answer for that row, and that'll give you a value of 2 if you follow the same procedure. So put in a 2 there. Okay, moving on to row 3 of the final matrix. We're multiplying row 3, which is M, by each one of these columns to give all your values along row 3 of your new matrix. So for 3-1, you're multiplying row M by column K, and following the standard procedure, multiplying them out. You'll get a 1. So we put that in there. Then for A32, you're multiplying row M by column F, which will give you a 1. So A33 is going to be row M by column M, which will give you a 3. A34 is going to be row M times column J, and that's a 1. A35 is row M times column A, and that's a 2. And finally, A36 is row M by column C, which will give you a 1. Alright, so you don't fall asleep if you haven't already. I've gone ahead and I've done the multiplication for row J and then A and then C. So I'm not gonna put you through all that. But this is your final second order matrix, two-step matrix. So what this tells you, Kate can communicate to herself twice. So let's see how she can do that as a two-step communication. So she can talk to Craig and she can ask Craig to call her back. What else can she do? She can talk to Felicity. And then Felicity can call her back to give her a message. Did you notice that the communication, the two-way communication between Kate and Craig is 0? Let's have a look at the diagram. So Kate can directly communicate with Craig. But can she communicate as a two-step through anyone else to get to Craig? The only other way to communicate with Craig would be to go through Felicity, but to do that she'd also have to go through Elise. That comes into the A cubed calculation. It is not a two-step, that's a three-step. So that's why there's a 0 between Kate and Craig for a two-step matrix. Now let's look at the diagram and see how many ways Mel can communicate with Alicia. There should be 2 ways. Now let's see if we can work it out by looking at the diagram. So remember, we're only looking at 2 steps. So Mel's got to go through one other person to get to Alicia. So we've got Mel to Jack to Alicia. And then we've got Mel to Felicity to Alicia. Are there any others? No, if she tries to communicate with Kate, she's got to go through, if she's got to go through Kate's path, she'd have to go Felicity, Kate, Craig, then Alicia. So no, there's only 2 ways, and that's what the matrix says, so it's correct. Now just looking at one more, so we've got Alicia to Alicia. So Alicia can go through Mel and then back to Alicia. She can go through Felicity back to Alicia. And then she can go through Jack. And then lastly, Craig. So she can get a message back to herself through 4 people. That's why there's a 4 there. Now I hope this has shed some light for you on the use of matrices in social networking. Let me know if you need any more help in this area, and I'll try and make it clear maybe with some smaller sums that don't get you too confused. Please like, share, subscribe, and check out my other videos. Thank you.